Digital data circulates like the blood in a human body. Through day and night, they carry the information that keeps the world working, making the world a better place. The advent of smart home devices and the Internet of Things has brought convenience and comfort to our modern life. Meanwhile, there are the misuse of the data, and that underlying malice is infiltrating the matrix of the healthy veins, threatening the wealth, life, and privacy at a scale beyond imagination. Who is the one to shield people against such an unprecedented crisis? Panasonic Cyber Security Lab. Panasonic Cyber Security Lab is a safeguard for the modern life of convenience and comfort. We analyze threats, eradicate breaches, educate and promote the mindset for corporate cyber security. We engage in exchanging thoughts from all fields and embrace innovation and progressive techniques. Panasonic has long been avant-garde in promoting your smart life intelligence. And we, Panasonic Cyber Security Lab, are a guardian securing the world from all cyber threats.
Hi everyone, thank you for coming to our session. My name is Jun Sato and my co-presenter is Jimmy, and we are from Panasonic Corporation. We greatly appreciate to get an opportunity to give presentation in HITCON 2020. Today, we will present first step in the quest for manufacturing cyber-resilient IoT devices. In this session, we introduce how we as a manufacturer try to make our IoT devices resilient against cyber attacks. Before I start the sessions, please allow me to introduce myself briefly. I am part of the Product Security Center, which is responsible for product security within Panasonic. My past experiences include being a system developer and operations related to cybersecurity. I joined Panasonic in 2019 and I'm currently involved in IoT security. To start, let's take a look at what is happening with IoT around the world. As you probably know, the number of cyber attacks continue to grow. In 2018, over 20,000 billion attack packets were observed on the Internet. Moreover, about half of these observed attacks targeted IoT devices, such as web cameras, routers, etc. What this means is that IoT devices are being targeted by attackers in addition to traditional information systems. This data shows the number of malware samples collected by Kaspersky, a notable security vendor. They have been collecting IoT malware samples since 2016. The number of collected samples more than tripled from 2017 in just the first half of 2018. Do you remember Mirai? It was a notable IoT malware discovered in September 2016. Since then, the number of IoT malware has suddenly increased. This is a very scary fact. So, besides some of these scary numbers, various articles have been published in the media related to IoT malware and the type of attacks they are causing. Some articles provide more details than others about the attacks or the techniques used by attackers to infect a large number of devices. And we, as a manufacturer, want to ensure that our products do not become infected. If our company name appears in any articles, not only is this a technical risk in that our products are vulnerable, but it also becomes a reputational risk in that the general public will know that our products are vulnerable. Thus, it is important for us to understand the threat landscape in regards to IoT devices and proactively protect our products from such attacks. Many IoT malware infects a large number of devices, and attackers use these devices to attack another target in a DDoS attack. Since most of these attacks involved devices for which the user has no idea that they are infected, much less know they are part of a larger attack, we need to protect our users proactively. It is important for us, a manufacturer, to provide devices that do not get infected, and thus our users do not unknowingly become part of such DDoS attacks. As these threats have continued to increase, various governments across the globe have become active in creating regulations to secure IoT. This slide lists some of the regulations related to securing IoT devices. In the United States, there are some federal laws as well as some state laws to govern IoT security. In Europe, the EU has put out some regulations which each of its member states are implementing. And China has a nationwide cybersecurity law to govern the entire countries, while Japan has issued some regulations as well. So, with all that was just said, how can we as a manufacturer take action to protect our products and users? This graphic shows the various stakeholders that surround a manufacturer like Panasonic. The important thing to note is that collaboration with these various stakeholders is necessary to improve product security overall. One other thing that we must always keep in mind is that our customers will always expect the manufacturer to ensure security of its products. And as a manufacturer, satisfying our customers' expectation is critical to our business. Next, I will introduce existing activities for product security at Panasonic. Cyber attacks are considered a major corporate risk at Panasonic, and preventing cyber attacks to protect company assets is critical. This chart shows the basic framework for risk management at Panasonic and is also publicly available on the Panasonic corporate website. To protect Panasonic from cyber attacks, three main pillars have been established. The first on the left is IT security, which focuses on securing the corporate IT infrastructure. This includes the corporate network, web servers, employee PCs, and other infrastructure necessary for employees to perform day-to-day operations. This is a team commonly established within most organizations. The other two are more unique to manufacturers such as Panasonic. Skipping over to the right is factory security, which focuses on securing the factories and systems that manufacture our products. Lastly, in the middle of the image is product security, which focuses on the security of various products that are shipped from our business units worldwide. The three teams collaborate on common issues, For example, sharing vulnerability information and any incident response that may be necessary. And now, focusing on product security, all activities for product security are to support the Panasonic brand, as it is critical to ensure that users of Panasonic products can have a peace of mind that the product is safe and secure to use. To accomplish this, there are two main activities: minimizing risk and incident response. The former is a group of activities undertaken prior to shipment, and the latter after shipment. The base for these activities is aimed to provide technical knowledge of security vulnerabilities and how to address them, as well as awareness to the development teams about current security trends. All activities for product security are designed to ensure security throughout the entire product lifecycle. The green item here are for pre-shipment, and the red item here refer to any post-shipment response. The Product Security Center at Panasonic provides support to internal developers throughout the product lifecycle. For some of the items, such as threat analysis and secure design, we provide guidelines and other supporting documents for assistance. This shows the product security incident response framework at Panasonic. The PSAT cooperates with external organizations such as FIRST, security vendors, coordination centers, and academia to coordinate any reported vulnerability in our products. PSAT has a publicly accessible contact where vulnerability can be reported by external stakeholders. Once the PSAT receives the report, analysis is performed to ensure that the report is legitimate and there is enough information for the developer to verify the reported vulnerability. After this is done, the PSAT will distribute the report to the affected division. As we just presented, Panasonic has been taking various actions to make our product secure, but challenges still remain. The response to these challenges is the reason why we started Panasonic IoT Threat Intelligence project. One of the main challenges is that typically incident response requires a trigger, such as an internal or external notification of a potential issue. This means incident response requires vulnerability information to be reported. We believe that by proactively collecting and analyzing the threat information by ourselves, we can utilize this information to make our products more secure. This was the concept behind the Panasonic IoT Threat Intelligence project. This is the overview of Panasonic IoT Threat Intelligence platform. This platform consists of three main parts. First one is collection. We have deployed a honeypot to collect attacks and malware targeting our products. Second part is analysis. We analyze the data collected by the honeypot. Third part is protection. Our goal is to strengthen overall IoT security in our products by utilizing the analysis data. Next, I will provide more details about each part. First is collection. This slide shows the current progress of the entire project. We have two types of honeypots. One is a software honeypot, and the other is actual Panasonic IoT devices. As you can see the photo on the right, we have a showroom that displays the actual products that collect incoming threads to itself. In addition to this, as a manufacturer, we have the ability to be able to deploy products in development. This can be a big advantage because it gives us the ability to collect threat information before shipment. We can take measures to address any newly discovered vulnerabilities or threats. This is an activity that was recently started. We currently have 2 observation points, Taiwan and Japan. In the near future, we plan to increase observation points and include US, EU, India, APAC, and China. Second part is analysis. The collection of malware targeting IoT home appliance is ongoing. Presently, we have collected many malware targeting various CPU architectures. More details on this will be provided later in the presentation. We perform behavior analysis specialized for IoT malware. Internally, we have defined IoT malware as any malware targeting the following CPU: MIPS, ARM, Arch64, PPC, and SH4. Moreover, we have automated the analysis process from malware collection to statistical analysis to reduce the amount of necessary manpower. If we find any interesting behavior in a particular piece of IoT malware, we will analyze it more deeply by hand. My colleague Jimmy will show some examples later. Third part is protection. For us, this is the most important phase in our quest to make our products more secure and resilient against attacks. We have started to share broad attack overviews and IoT malware analysis reports to product developers this year. Our next challenge is to analyze risks against our products, including those that are under development. We plan to categorize and analyze attacks using frameworks such as MITRE-ATT&CK. Then we will analyze any targeted vulnerabilities against our products to assess countermeasures specific to our products. Finally, we hope to provide this analysis as helpful feedback to our developers so they can utilize this feedback to make products more secure. This is a quick summary of some data points from November 2017 to June 2020. We have observed over 600 million attacks and captured 56,000 malware samples. About 20% of these samples have been categorized as IoT malware. Within those samples, we observed an interesting example that attempted to infect a home electronic device by placing a malicious file. For the observed malware, after analysis, it was found that the top 10 destination IP addresses that they attempted to connect to were malicious sites. And the top 3 destination countries were USA, China, Japan. In the next part of the presentation, Jimmy will show some analysis examples.
Thank you, Sato-san. Hi everyone, I'm Jimmy. Now I'm working at Panasonic Cybersecurity Lab. I was a software developer, but I have huge passion for cybersecurity, like IoT security and penetration test. So I joined Panasonic in 2018 and involved in IoT security. In this session, I will talk about the analysis examples of the collected threat from our system. This information will be provided to our internal developers to make them understand the current threat we are facing. This is the total attack chance from our system. There are two peaks in December 2019 and June 2020. We will give a deep analysis for these two peaks later. As you can see the blue bar, we also can observe that the total attack number decreasing since February 2020. The peak in December 2019 is the attacks targeting to Microsoft SQL Server. The attackers try to use weak password to log in and run the malware on our honeypot. We also observed that the attack number of Microsoft SQL Server decreasing continuously since December 2019. As you can see the blue bar on the figure, the attack number from 600 million to 0.25 million. The second peak is related to the code stranger, which is an UPnP vulnerability. It allows hackers to perform UPnP reflection attacks. We suspect attackers or researchers want to know how many devices are vulnerable, so we got many attacks around the vulnerability has been disclosed. Let's see the detailed trend in the second quarter of 2020. The attack targeting to Microsoft SQL Server is still in the first place in April, but it dropped it suddenly in May and get out of the top 5 ranks. This result matched to the figure in the last page. The attack targeting to Microsoft SQL Server is decreasing, and the UPnP attacks raised since May. You can see it become the third place in May, and then become the first place in June. That's why we see the second peak in the last page. And the top 2 originating countries in May and June are both China and the USA. There are many UPnP attacks from China and the USA. Lastly, we observe that Telnet, SSH, and the UPnP are on the top 5 rank constantly, because those protocols are very commonly used for many devices. Let's see the trend of attack source country. In the first peak, the most attacked source country is China, and the second place is Taiwan. And see the second peak, the most attacked source country is also China, and the second place is the USA. As I mentioned in the previous page, most of the attacks are targeting to UPnP in the second peak. This is the detailed trend of countries in the second quarter of 2020. You can see China is in the first place in this quarter. And China is not only in the first place in this quarter, but also many other months, including the 2 peaks we saw previously. We suspect this phenomenon could be caused by political issues or geographic issues. And when we investigate the attack protocol from China, we found that there are many attacks against UPnP and the Microsoft SQL Server. This figure is the attack trend against home IoT appliances. The attack number of security camera is the most, The reason why is open some common services, like web, UPnP. Other appliances don't open services as much as security camera, so the attack number is lower than security camera. Another reason is some appliances use our customized services. The port number and the interactive method are hard to figure out, so the attack number of some appliances are very limited. For example, wash machine, refrigerator, and so on. This page is a deep analysis of the attack against security camera. The top two attack source countries are China and the USA, and almost all attacks are against UPnP and HTTP. We also analyzed the attack for UPnP, and observed that there are many msearch messages. As you can see the red box, there are many msearch messages. And it could be attackers who want to find the vulnerable device for SSDP reflection attack and exploit the devices with this vulnerability in the future. Here are the trend of collected IoT malware from our system. 66% of malwares are known, and 34% are unknown. Our definition of known malwares is that the malware can be found on VirusTotal. Our system collects 150 to 170 samples per day, and we find out there's no direct correlation between the number of total attacks and the number of collected malware, likely due to the most attack attempt to be scams, but not real attacks. Most of the malware we collected is targeting to PC and servers. The i386 and the MD64 are the most, and around 30% of them belongs to IoT architecture. ARM and MIPS architecture are the major type of them. Apart from ARM and MIPS, we also collect many malware of PPC and SH4 architecture. And we also classify the IoT malware family we collected. As you can see the right figure, and the result shows most of the malware family is GetGift, have 61%, and the second one is Mirai family, have 34%. These two families is over 95% of the malware we have collected. Besides the malware collected by our honeypot, we also open the Sandbar service on our IoT appliances, and don't enable any authentication mechanism for that, which means anyone can access the shared folder and perform create, read, upload, and delete file on that. There are three kinds of suspicious files have been discovered on our appliances. Firstly, we found 5 malware samples have been placed on June 2018. They are the payload of Sambacry attack. I will give you a detailed packet analysis later. Secondly, we found 4 suspicious files from October 2018 to December 2018. The file name is unmap-test-file. We believe that those are temp files when hackers or researchers perform the unmap scan. Finally, we observed a malware called Tenga, which also exploits the Sandbar protocol. The difference between the first finding and this finding is that This sample is trying to implement PE malware, which is Windows malware. And you can see the file extension here is exe. This is the detailed analysis for Sambacry attack. The attacker will use the net share email command to list all of the share folder on our appliances. After that, they will try to upload the payload. As you can see here, they upload a SO file extension to share folder with random file name. And this is the payload of Sambacry. And then they will try to load the malware by enumerating many physical paths. You can see here, this is the real path they try to load the object. But they fail to trigger the payload. All of the response from our appliances are error. The error code is status object name not found here, which means the attacker cannot load the object successfully. After the attempt, the attacker will delete the uploaded file, but the attacker leaves some files on our appliances. We believe that their attack script must have some problem, so they leave some files on our system. Now, I'm going to share 3 case studies of IoT malware analysis. We will analyze malware samples regularly and provide reports to internal developers. The purpose of malware reports is to enhance the awareness of developers, to let them know the popular exploits or new exploits, and to try to avoid them when they develop a new product. This sample is called Echobot. It's a Mirai variant. After intrusion, this malware will use PRCTL function to change the process name to a random string. And this is the random string. And the list result is generated by our sandbox. And this mechanism can evade some defense rules, like some IDS rules. After changing the process name, the malware will use scanner to spread itself. The scanner will according to the computing power of IoT device to enable different functions. If the CPU number is 1, which means the computing power is not enough, the malware will just use the exploits here to spread itself. Moreover, if the CPU number is more than 1, the malware will enable SSH and the Telnet scanner additionally. Most of the exploits here are command injection for IoT devices and open source projects. As you can see here, this is a real example in this malware. They will try to use wget to download the malware and try to execute it. And after execute it, it will try to delete and clear the footprint. The table key is an obvious characteristic from Mirai family. It can be used to encrypt and decrypt the important strings. The original Mirai used the key DEAD BEEF, and this malware modified the key to DFD AACFD. And we can get the C2 address and the default credential by using this key. And the IP address of C2 is from China. We also found some typical DDoS function in this sample. They are nothing special than original Mirai. We have collected many samples with different architecture for this malware, including the common CPU architecture of IoT device like ARM, MIPS, PPC, SH4, and so on. And the second case study is Echobot. This malware is also Mirai variant, but it rewrites in Golang. Golang malware is hard to analyze because there are many redundant functions when we try to reverse it. And you can see there are over 5,000 functions here. But we still can find some way to trace the main logic. And this malware is similar to typical Mirai, using some exploit and the SSH and the telnet to spread itself. And you can see the exploits here. But the interesting things in this malware is this malware is recognized as not malicious in VirusTotal, and they add some coin miner functions in this malware. And this sample is the MIPS architecture, which is also usually used by IoT devices. The final case study is called Sandbot. It's a variant of the Tsunami family. We found this malware is packed by UPX when we perform the stream analysis. So we can use UPX to unpack and analyze it. And you can see the figure here. This is the characteristic of UPX, and you can see the UPX stream in this figure. And this malware leverages telnet with weak password to spread itself. After intrusion, it will use IP tables to block the telnet connections, which is very smart. And you can see this figure. This malware uses IP tables to block TCP with destination port 23. So other malware will not have a chance to infect this device in the same way. This malware uses a stream mapping table for encrypt and decrypt important streams. You can see the figure here. X represents 0 and the M represents 1 and the at represents 2 and so on. So we can get the C2 address by using mapping table. And you can see the C2 address here is bigirc.host. And the country of the C2 server is from Panama. But other information is protected by WhoIsGod. And the most interesting part of this malware is this malware supports the command to deploy the bot as C2 server. And you can see the full commands here. This command will download the ngircd, which is an IRC server daemon, and they use IP tables to accept the TCP connection from 6667 port. By this command, this malware family can switch the C2 server easily. And this sample is the ARM architecture which is also usually used by IoT devices. And that's all for the analysis example for our system. I would like to hand this presentation over to Sato-san.
Thank you, Jimmy. We have provided an overview to our project and some data analysis so far. This last section will talk about remaining challenges. Our ultimate goal is to strengthen overall IoT security. Currently, we are proactively collecting and analyzing incoming threats. For the next step, we plan to categorize the collected attacks against our products, including those that are under development, using a framework such as MITRE ATT&CK or another similar framework. Analysis of any targeted vulnerabilities by malware will continue, and we will assess countermeasures for our products to provide helpful feedback to developers. Moreover, we will collaborate with industry to see if global trends match what we are seeing attack against our products. Finally, let me introduce our platform. We have made visualizations to show when products are actually under attack. As I mentioned earlier, there is a showroom and where IoT appliances are deployed to collect incoming threats. Top left shows the attack flow from the internet to these IoT appliances. As you can see, there are some objects with Chinese characters. This shows attack frequency. If an appliance gets attacked, the object rotates faster and the object size becomes bigger. Moreover, if the number of attacks reaches a preset threshold, a big Chinese character is displayed. Bottom left is a picture of the actual showroom. When an appliance is under attack, the red lamp turns on. Top right is a graphic that shows our honeypot being attacked from all over the world. That's all our presentation. Thank you for listening.
Digital data circulates like the blood in a human body. Through day and night, they carry the information that keeps the world working, making the world a better place. The advent of smart home devices and the Internet of Things has brought convenience and comfort to our modern life. Meanwhile, there are the misuse of the data, and that underlying malice is infiltrating the matrix of the healthy veins, threatening the wealth, life, and privacy at a scale beyond imagination. Who is the one to shield people against such an unprecedented crisis? Panasonic Cyber Security Lab. Panasonic Cyber Security Lab is a safeguard for the modern life of convenience and comfort. We analyze threats, eradicate breaches, educate and promote the mindset for corporate cyber security. We engage in exchanging thoughts from all fields and embrace innovation and progressive techniques. Panasonic has long been avant-garde in promoting your smart life intelligence. And we, Panasonic Cybersecurity Lab, our guardian, securing the world from all cyber threats.